In this video we're going to look at a simple capacitors question. Pause the video now and try both parts of this question. Part A. Use the current at t equals 0 to show that the resistance R is 600 kiloohms. So the current at t equals 0 is 5 times 10 to the minus 6 amps because it's 5 microamps. So how can we use this? Well, what other information do we know? We obviously know it follows this decay, so you could be tempted to use one of the exponential equations, but we know that when we close the switch here, the capacitor is charged 3 volts. And we're looking at the current when it's discharging immediately after the switch opens. So basically we can assume that V is 3 volts. We know what the voltage is, we know what the current is, so we know that resistance is V over I, which is 5 times 10 to the minus 6 amps. So 3 volts over 3 times 10 to the minus 6 amps. So I'm having an absolute fail. That should be 5. Sorry, I'm just having a complete error here. This is why you always write out your calculations in case you make a mistake. So it's 3 volts over 5 times 10 to the minus 6 amps, and that gives you 600,000 ohms, which is 600 kilo ohms. So really simple despite my mistake. Use the graph to find the time constant and calculate the capacitance C. So we need to know what the time constant is. The time constant is the time to fall to 37% of the original value. That's really important you remember that definition. Without that, you can't answer this question. You also need to know that the time constant equals RC, so the value of the resistance times the value of the capacitance. So now we can work out what the time constant is. So 5 times by 0.37 tells us what the time constant is going to be on the graph, or allow us to find it. So 5 times by 0.37 gives us 1.85 microamps. So we can, on our graph, 1.85. So we need to use a ruler here, really. It realistically is going to give us what, 14.75, let's say. Now we could find a second time constant and just check that we're doing this right. So we could say 1.85 microamps times by 0.37 is 0.68 microamps. So 0.68, basically 0.7, so that's here. So this time here represents the time constant. So the time constant would be 27 minus 15, which is 12 seconds. So maybe now what we do is take the average of the two. So 14.75 plus 12 over 2. Which is 13.3 seconds. Now we can use this equation here to work out the capacitance. So the time constant over R, so 13.3 over 600,000, which is 2.2 times 10 to the minus 5 farads. Or you could say 22 microfarads. that would also be fine, but the answer is given as farad, so we may as well write it in standard form.